All right, our goal is to do 4 problems today. I love this problem. It is something you haven't seen before, but it's not very difficult. John can paint a house in 32 hours. Eric can, yeah, it's a good question. A lot of people, but, so John paints in 32 hours. Eric paints in 24 hours. How long do you think it will take them to do it together? Talk, come up with something. Go. Okay, and stop. Shh. All right, so let's talk about it because this is what I want. So like when I do exercises like this, I don't really expect anybody to come up with the exact answer, but I want you to be able to reason through it. So here's what I'm wanting to happen in your brain. And the first part is this. Automatically, people jump to the average. They would say 28 hours. And I want you to think this through really quick. If Eric can paint it in 24 hours on his own, why would it take them longer to do it together?
John's slow. Yeah,
Does everybody agree it's got to be less than 24? Yeah. Like they're working together. So it's got to be less than 24. In fact, let's think about it even a little bit more critically. Suppose that it took Eric 32 hours as well. It takes them both 32 hours to do it on their own. They're working together. How long would it take? It would take 16. Suppose that they were both faster and it took them both 24 hours. How long would it take them together? So you know right now, via just a little bit of logic, that it's going to be somewhere between 12 and 16. No, it's not 14. Sorry, Aiden. Okay, so let's figure it out. There's a formula that you need. This is a formula that if you were to take the ACT, they won't give this to you. Okay, this is what you need to know. And simply that rate is equal to distance divided by time. If you ever forget that, I'm going to give you a way to remember it. I was traveling to work today at a rate of 42 miles per hour. Okay, it was tough on the freeway, just going at 40. The semi flipped over. I thought I'd take my time, so I did. Notice, right up by Geneva. Yep, right around there, yep. So, notice how I say miles per hour, distance over time, that's equal to rate. See how that all connects together? If I multiply both sides by t, I get rate times time is equal to distance. And if you divide both sides by rate, you get time is equal to distance divided by rate. So you've got 3 equations that you can use. But the one that I think is most important for us to talk about is I'm going to substitute, instead of D, I'm going to use W. Rate times time equals the amount of work that you get done. And really in math, I mean, I would say this is probably one of my worst attributes as a teacher, is that we tell you what to do, but we don't always know why we're doing it. So let's try to figure out what the heck rate times time equals work means. So let's use Eric, for example. Eric, he paints 1 house every 24 hours. Everybody agree that's his rate? Suppose that he were to work for 48 hours. How much work does he get done? 2 units of work. See that? Everybody see that work? See that take place? Kind of understand what we're doing a little bit better now? So, people often don't label it like this, and you don't have to. This may seem like kid mathematics. And I want you to know that my goal is anytime I see a word problem, I don't need one model for me. I can figure it out. So where do I start? Here's where I start. Very basic. I write down John's work. And by the way, when I was younger, I did not write this out. This happened as I became a mature mathematician and started to organize my work better. Plus Eric's work is equal to how many houses? They want to paint 1 house. If they're painting 2, I'd put 2. Okay? So, John's work will be his rate times his time. John's rate is 1 over 32 times his time. That's his time to paint 1 house. But they are painting 1 together. This time represents how long does it take them together. 32 is on its own. So if it was 32 on its own, you're right, we'd plug it in. But this is the time together. Plus Eric's rate, 1 over 24, and we're multiply that by his time. Or I should say their time together, that's equal to 1. So we will find common denominators. And we have t over 32 plus t over 24 is equal to 1. Common denominators, most people multiply the top and bottom by 24, top and bottom by 32. The common denominator is 96. Do other people see that? Okay. 32. That's all right. 32 times 3 is 96. 24 times 4 is 96. But we'll just multiply by 24 and 32. That's what most people would do. So 24 over 24, 32 over 32. Please solve there. I have to go rescue the people in the hallway because we have people who are... they responded to me, so I did not need to get angry, which is good. So, what do we got? 768? Yeah, so you got 24 and 32. That makes 56t over 768 is equal to 1. How do I solve for that? Multiply by the reciprocal, so multiply by 768 over 56. And I get t is equal to 768 divided by 56.
Can we cross multiply?
Sure, yeah, 1 over 1, cross multiply, do the same thing. Question. So if I multiply by the reciprocal, those go away. I'm left with t. Somebody 768 divided by 56, I get 13.71. 13.71 hours. Not bad, huh? You were close. Close counts in horseshoes and hand grenades, but other than that, not too much. Yep. So that's the time it takes them together. Notice how we came up with a reasonable solution right away. We move along. We're not going to do Matt. We're going to do John. Sorry.
What's your beef with Matt?
Exactly.
What did Matt do to you?
Good point.
What's Matt?
Exactly.
I don't really know very many guys.
Matthew. So, John and Sue can paint the house in 5 hours if they work together. Okay, they're working on smaller houses than John and Eric work. Okay, so John and Sue, they can paint a house together in 5 hours. Okay, if John can paint a house twice as fast as Sue, how long would it take John to paint the house alone? See if you can talk with the person next to you and see why is this problem different than the last problem. Go. Okay, what makes this different?
We know the answer, but we don't know what John is using.
Okay, so we know the number of hours, we don't know the rate, right? We don't know the rate. We know how the rates compare, but we don't know the actual rate. Can John paint a house every 10 hours, every 7, every 5, every 12? What is his rate? We don't know that. So to try to make sense of this, because people often make mistakes here, suppose that John's rate was 1 house every 10 hours. Okay? Suppose that was John's rate. What would Sue's rate be? 1 over 20. So right away, often people, they try to come up with the equation right away. I like to kind of think about it before I just make my equation. So I know John's rate is going to be, say, 1 over x times, how much time does it take him? 5. So again, we are using rate times time, plus what would Sue's rate be? 1 over 2x. Now, you can see that people might be more likely to put the 2 underneath there, right? Because they're like, well, John's twice as fast, right? But because I modeled it with an example, I can see that this is going to be the 2x and this is going to be the 1x. All right. Yes. So we are modeling rate times time is equal to the amount of work done. So John's work is his rate, which is 1 over x, times his time, which is 5 hours. So times the 5 here as well.
Oh, I thought, okay.
Yep.
I figured like just
Nope.
Yeah.
So it takes, we know that together it takes 5, so 5 can go into there. So now I just solve it. I have 5 over x plus 5 over 2x is equal to 1. Yep, top and bottom by 2, and we get 10 plus 5 is 15 over 2x is equal to 1. You could cross multiply there, or just multiply 2x over the other side. 2x is 15, so x is 7.5. So I was dividing by 2x, so I just multiply both sides by 2x. Or you could flip it, or you could cross multiply. All sorts of ways in which you can come up with 2x is 15. Yeah, so let's try to think about it now. What does that 7.5 mean? It means John paints one house every 7.5 hours, and Sue paints one house every 15 hours. Yeah. Yep. Well, it says, how long would it take John to paint? I guess 7.5 hours. If they ask Sue, then it would be 15 hours. So 7.5 is the answer. Okay. So if you go 15 over 2x is equal to 1, I just multiply both sides by 2x. The other way you could do it is 15 over 2x is equal to 1 over 1. If you cross multiply, you get 2x is 15. And the other way to do it is 15 over 2x is equal to 1. If you simply just flip them both, you get 2x over 15 is equal to 1. And just multiply both sides by 15. All sorts of ways to handle the fraction. All right, classic problem. 2 planes are flying toward one another. The plane flying from LA to New York, that's a long flight, is traveling at 500 miles an hour. The plane flying at New York to Los Angeles is traveling at 650 miles an hour. How long have they been flying when they meet if the cities are 2,450 miles apart? I like to start with a drawing. I always thought that being an air traffic controller would be an interesting job. Turns out that, do you know that what's generally rated as the 3 most stressful jobs in the United States? The president, being an air traffic controller, and then stock market analysts. Those are stockbroker. So tend to have a lot of stress in their life. So I always worried that those 2 planes will crash, right? So they got to be on their game. All right, so we know that they are 2,450 miles apart. So again, I'm not showing you guys how to do the problem. I'm just showing you, like, this is what comes off my mind. I'm going to just draw a picture. I'm going to draw an arrow like LA to New York. Let's see. LA to New York, that's 500 miles an hour. And then New York to LA, that's 650. What's that? Yeah, well, one's a bigger plane. One's a bigger plane. Does it go as fast, carrying more people? It's just after Thanksgiving. People are at Thanksgiving dinner. We're carrying more weight. Let's talk about the real reason why they're going different speeds, folks. There's a headwind, right? There's a headwind. So a wind, like when you're driving a car, you got a wind that's coming against you, so you're going to go slower. Yeah, one's going against the wind, one's going with the wind. Okay. So we got that. So this is definitely a rate is equal to distance over time problem. Now, All mathematicians would love it if they could teach the students and then students would be able to do problems on their own without seeing the model, right? Like that is the goal, right? So there's two ways to teach this problem. There's one way that's kind of really slick and easy, but it just kind of works in this situation. I don't want to just give you that way. So the other way is really not that bad at all, but it's going to help you as you tackle other problems. So here's how I try to think about this when I first look at it. Okay, I want you to think very carefully. When they meet, is the distance that they traveled the same? Is the rate that they traveled at the same? Or is the time in which they traveled the same? Talk to your peer. Which one's the same? Talk. Go.
Yeah. Wait.
Oh, well, when they meet,
Wait, hold up.
the distance is going to be different. Oh, when they
Same time, not.
And stop. Jordan, everybody give Jordan a round of applause. Yeah. Jordan, can you stand up? Can you stand right there? There, she's going to be the plane from LA. I'm the plane from New York. No, right there. Okay. And we're going to walk towards each other, okay? You're going to walk quickly. I'm going to walk slowly. You guys tell me, is my rate, distance, or time the same as hers? Ready? Go.
time.
There's no way that the rate was the same, right? And there's no way in heck that the distance was the same, right? The time must be the same, right? Give her a round of applause. Yeah.
My friend.
Would she do it better or worse on hockey skates?
Definitely better.
Okay, all right. So here's what I want to do then. I know that their times are the same. So I'm going to say that the LA time is equal to the New York time. So I don't want an equation that says rate is equal. I want an equation that says time is equal. See that? So if I want an equation for time, I always start with this guy. I'm going to multiply both sides by t to get RT is equal to D. And then I'll just divide by R. So I get time is equal to distance over rate. So I think that that's a really good way to think about distance, rate, and time problems. Kind of what thing was the same? And in this case, time. So we're going to go for the LA time. The LA time is going to be the distance divided by the rate. Well, what is the rate at which the LA plane is flying at? 500, okay? And then we have the New York one, 650. So now what we need to do is we need to come up with their distances. And we don't know their distances, do we? And would everybody agree that the New York plane definitely traveled longer? Okay, so I'll draw a line like right there. How's that? That look good? Okay. So this is one trick that comes up in many, many word problems. And so I want you to see it. So the last thing you're going to have to really think about critically today for the most part, I'm going to call this distance x. So we're going to call the New York distance x. Anybody know what I would call the LA distance? You could call it y, but I want to call it something that involves x. Yeah, it would be 2,450 minus x. Do you see that? So Lily said y, which is correct, but we would agree that x plus y is 2,450, right? Like if you were to add them together. So therefore, y would be that 2,450 minus x. So now I've got that distance, 2,450 minus x. What should we do? Cross multiply. So I get 500x equals 650 times 2,450. It's not me climbing, but I'm very, very happy to think that you think I could be that person climbing. Yeah, I do. I do. I enjoy climbing. Spent my summer in Colorado this year, so. The rock gym? I need a higher wall. All right. All right, so we've got 1,592,500. It's like my bank account. Maybe after I get part of my 17.6 billion refund. Minus the 650x, okay? Plus 650, so I get 1150x is equal to 1,592,500. So we divide them. We divide by 1150. Maybe that's more like what I'll get for my refund. 1,380. What? It's not dollars. It's, okay. Duh. 1,384.78. So what does that 1,384.78 represent? Is it a rate? Is it a time? Is it a distance? It's distance. And it says how long have they been flying for? So how much time have they been flying for when they actually meet? So is that time? How do you figure out time? What do? You take a distance and divide it by a rate. So if I just take this and divide it by 650, that will give me their time. So I know the distance, but their time is going to be 2.13 hours. So we are trying to determine time. Time is equal to the distance divided by the rate. The distance was 1,384.78 and the rate was 650. If you were to, you could plug it in here and do 2,450 minus that and divide by 500, and that would give you the same time. Doesn't matter which one you choose.
Okay.
Yes?
Why did you say, like, there's, like, further back in time that the news, like, was traveling
A longer distance. Yes, longer distance. So the New York plane traveled 1,384 miles. This one would be less than that. That's what I meant. So on a test or anything, I would make sure if I say long, that I delineate what is that referring to, time, or if it's referring to distance. You know what I mean? Because that's kind of misleading, isn't it? Yeah. Good question. Okay, last example. After robbing a bank, the robber gallops off on his horse at 14 miles per hour. 10 minutes later, the marshal leaves in hot pursuit at 16 miles per hour. What's that? Marshal? It's the police officer, the marshal. How much time does it take the marshal to catch up with the bank robber? So you need to now decide right now what's the same. Have they been traveling for the same time, the same distance, or the same rate? Talk. Go. Which is it? Go. Okay, what's the same? The rate, the distance, or the time? The distance is the same. One overtakes the other at some point. The distance is the same. So because the distance is the same, I would like to use the equation rate times time is equal to distance. I remember the first time I taught this was just really, really bad. But I think that approach, don't you think that helps? What is the same? And then find an equation that equals that, right? Yeah. So we're gonna that's the approach I'm taking. So we're gonna say Marshall distance equals robber distance. Marshall distance equals robber distance. Okay. Well, the Marshall one's really easy because the Marshall's distance is his rate times the time. What's his rate? So 16 times t. Great. The robber's distance is going to be now, this is the interesting part to think about, okay? So, do you agree in terms of time, the robber's actually been going for a longer amount of time, right? So the 14t, that's just, that part. But we got his head start, right? So let's add on the distance of his head start. The distance of his head start is going to be his rate. How fast was he traveling at this time? 14. And for how much time was he traveling? 10 minutes, which is 1/6. We're in hours, right? So he's traveling for 1/6 of an hour. Okay, let's come back here. Number one, we're working in hours, not minutes, right? So we have, look here, rate times time, rate times time, rate times 10 minutes, or 1/6 of an hour. But they're all rate times time. Do you see that? That's what's beautiful. Okay, now it's easy. I mean, the math is easy. It's just modeling it. That's the tough part. So I get 16t is equal to 14t. 14 times 1/6. That would be 14 over 6, or 7/3. Subtract the 14, I get 2t is equal to 7/3. People got lost when I did this first hour. I like to do this when there's a fraction on the other side. Instead of dividing by 2, I could multiply by a half, right? That's the same thing as dividing by 2. So I'll multiply this side by a half. So I get t is equal to 7/6. So that would be 1 1/6. Or in other words, 1 hour and 10 minutes. And 1 1/6 or 7/6, I get full credit on a test. I think an hour and 10 minutes, that kind of sounds nice, doesn't it? Sounds nice? Good. So, you've seen these problems modeled. That doesn't make them easy, but you are ready for your last part of your assignment. I've told you so far to do problems 1 through 10. I also told you to do 12 and 13. And now you have 15, 16, 18, and 19. Okay? Folks, be safe on the roads. Be safe on the roads.